Hey guys, Mr. Gucci here, and I'm going to be doing your notes video for this independent work Wednesday activity, which is combustion reaction. So we did synthesis, we did decomposition, and now it's time for another fairly simple reaction type called combustion. Okay, now what is combustion? Combustion means to burn something. So anytime you've seen something lit on fire, you are almost always seeing some form of a combustion reaction. All right, a combustion reaction is where a compound made of carbon, hydrogen, and sometimes oxygen rapidly combines with oxygen gas O2 and produces carbon dioxide and water. And of course, lots of energy. If you've ever seen a campfire or sparkler or some kind of explosive, all of those were pretty much combustion reactions. Now, combustion reactions are interesting compared to the other reactions we've learned because the products are always the same. So long as you see some compound made of a certain number of carbons, a certain number of hydrogens, and maybe some number of oxygens combined with O2, then you will always have carbon dioxide and water as the products. Wood is just some combination of carbons, hydrogens, and oxygens that you combine with O2 gas and it burns. And when you burn a log, it produces carbon dioxide and water. Have you ever wondered why a log seems to shrink down as you burn it into ash? That's because a lot of what was the wood is being released as carbon dioxide gas and water vapor into the air. So it looks like it's disappearing, when in fact it's just turning into gas. Have you ever lit a marshmallow on fire? Same exact thing. Burned a piece of paper. Pretty much anything you lit on fire is something like this, okay? And again, you can identify a combustion reaction because the reactants are something with CHs or CHOs and O2. The products are always carbon dioxide and water. So predicting the products here is going to be very simple. All right, on the worksheet for combustion, as far as you're concerned, you can just copy and paste the products as carbon dioxide and H2O, and you can just paste it all the way down your homework sheet. Predicting the products are easy here. So then what's the issue? The issue is that while predicting the products are easy, because they're always the same, balancing can be very tricky. By far, balancing combustion reactions is the most difficult balancing activity you are going to do. So whereas you're going to just copy and paste CO2 and H2O down your entire homework worksheet, okay, you're going to be spending more time balancing. So if balancing has been going well for you, that's great. That's great. Keep with it. Okay. If you're having some trouble balancing, well, this is going to be where we hopefully make you into a better balancer. You're going to probably want to have a separate sheet ready to go to work on this. Okay. So again, now I said that combustion was a CHO compounds called carbohydrates. Technically speaking, we also say that some metals combust. For example, I did a video where I lit steel wool on fire. I've been lighting magnesium metal on fire. These metals combine with oxygen rapidly in a burning process. And so sometimes we call these combustion, but really they are actually synthesis reactions, all right? Because you have two elements combining to make one, all right? Notice you're not making carbon dioxide and water, you're just making one. So I just want you to know that sometimes certain metals can combust. That's not what we're talking about here today, though. Here we're talking about compounds made of carbon, hydrogen, and oxygen. Now listen, writing the products is easy. The products are always carbon dioxide and water. The tricky part is balancing, so here are some tips for you. First, you're going to want to balance the carbons on both sides first. So first step always is balance the carbon atoms. Second step is balance the hydrogen atoms. And the third step is to balance the oxygen atoms, but you can only balance the oxygens by changing the coefficient in front of the O2. All right, you can only balance the oxygen by changing the coefficient in front of the O2. And the reason for this is because there are oxygens in both carbon dioxide and water on the product side. And so if you're like, oh, I need more O2s, I need more oxygens, you're not sure what to change. So when you're doing this, you always balance the oxygen last and do so by changing the coefficient in front of the O2. Now, sometimes you're going to end up with a weird situation where you need a fraction, let's say you need 5 oxygens. Well, that would be 2.5 O2s. But you're not allowed to have a half as a coefficient. And so then what you'll do is you will double everything in the reaction and then try again. So just remember, carbons first, hydrogen second, oxygen third. If oxygen does not seem to be balancing, double all the coefficients and try again. This is really one where I just got to show you a demo, all right? I got to show you a sample. So here we go, all right? Now, again, any compound made of C, H's, and O's plus oxygen, that would be a combustion reaction. Let's see here. I'm going to start with something basic. C2H4, okay? Plus oxygen gas. Now, if I saw this as one of the problems that I had to do on the homework, I'd be like, that's no problem product-wise, because I'm always producing, it doesn't really matter which order you put it. I'll put CO2 and H2O. That's what you're always starting with. So predicting the products here could not be easier. And now, though, we have to balance. All right, so let's see here. Carbons. We've got 2 on this side, and we've got 1 on this side. So I'm going to put a 2 in front here to balance it. Hydrogens. We've got 4 here, and we've got 2 here. So I'm going to put another 2 to get the same number of hydrogens on both sides. Now watch this. So far, so good. It's been pretty easy. What about the oxygens? Now on this side, I have 2. And on this side, how many do I have? Well, check this out. There is oxygen here, but also over there. So let's see here. 2 times 2, the carbon dioxide gives us 4 oxygens. 2 times 1, this water gives us 2 oxygens. Altogether, we have got 6 oxygens, all right? 6 oxygens. So if we want to balance it on the other side, we have to put a 3 right there. That'll give us 6 on this other side. And there you have it. You see, that was far more involved, the balancing question, than we've had before, especially, in fact, almost entirely due to the difficulty we have when balancing the oxygens. Remember, both of these compounds in the product, they both have oxygen, so you got to make sure you account for them both. All right? Now, again, anything I make up here is a good balancing combustion problem. So let me come up with another one. Here we go. So I'm going to do C3H8. Okay, C3H8 plus O2. And what do I get? Well, again, coming up with the products is easy. It's always carbon dioxide and water. The tricky part is the balancing. So, C, over here, we've got 3 carbons and we've got 1 carbon over here. 1 carbon, 3 carbons. So I'm going to multiply this by 3 to get us 3 carbons. All right, good. Carbons are now balanced. Over here, we've got 8 hydrogens, and I'm just going to write 8 here because I don't want to do all those slashes. And over here, we have 2 hydrogens. So I'm going to multiply it by 4. Multiplying it by 4, and now we have 8 on this side. Okay, last of all, we're balancing the oxygens. Always last. Now on this side, we have 2. On this side right here, we have got to remember both of these things have oxygens. We have 3 times 2 is 6. 4 times 1 is 4. 4 and 6 together is 10 total oxygens. 10 total oxygens. We've got 6 from this, and we've got 4 from this. 6 from the carbon dioxide, 4 from the H2O. All right? And so we've got 10 over here and 2 over here. These are all numbers. So I need to get 10. I'm going to put 5 in front here, and now we have 10. Okay? Again, it's not so bad. The products are always carbon dioxide and water. And so long as you remember the balancing trick, it goes okay. Start by balancing the carbons, then balance the hydrogens, and lastly, balance the oxygens by just changing this value in front of the O2. All right, just change that value in front of the O2. Let's try another one. This one I'm going to do one that's a little trickier. Here we go. C4H10 plus O2 yields always, the products here are CO2 plus H2O. Okay? Always. That's the easy part. The hard part is the balancing. So let's start with the carbon. We've got 4 carbons over here. We've got 1 carbon over here, so I'm going to put a 4 in front. I'm going to multiply it by 4 so that now we have 4 over here. Okay? Next is the hydrogens. Okay, the hydrogens. We've got 10 hydrogens over here. Oopsie. 10 hydrogens over here. And we've only got 2 hydrogens over here. So what I got to do is I got to put a 5 in front here. And now 5 times 2 is we have 10 hydrogens. Okay? Now comes the part of the O2. All right, let's balance the oxygen. Let's balance the oxygen. So on this side, we have 2. Now on this other side, check it out, folks, check it out. We've got 4 times 2, which is 8 oxygens on this side. 5 times 1, which is 5. We have got 13 oxygens on the product side. 13. Now, what number right here would we need to put to get a total of 13? Notice how whatever number we put gets doubled. So what times 2 equals 13? All right. So x times 2 equals 13. A little bit of quick maths here. We find that the number that should go in front there is 6.5 or even 13 halves. Even 13 halves as well. You know, you could keep it as a fraction if you wanted to. All right. So the number that would make this work is if we had 6.5 oxygens there. But here's the problem. Coefficients have to be whole numbers, you might recall. They have to be whole numbers. They cannot be decimals. They cannot be fractions. It has to be a whole number ratio. So what would we do here? How would we change this? Well, the way that you are recommended to change this is just multiply everything by 2. Every coefficient gets multiplied by 2. It gets doubled. We double every single coefficient. Let's see what this does for us. Let's see what this does. Okay, so first of all, this was right here a 1. Now it gets doubled and it becomes a 2. This was 6.5. It gets doubled and it becomes a 13. This was a 4. It gets doubled and it becomes an 8. And this 5 gets doubled and it becomes a 10. All right? And so now we have balanced it. Now everything is the same on both sides. But everything's been doubled. So now we got 8 carbons and 8 carbons. Okay? We have got 20 hydrogens. We've got 20 hydrogens. Okay? We have got 26 oxygens on this side and 26 oxygens on that side. So that's something to keep in mind. Okay? You will get situations where, since this is an O2, it can only ever give you an even number. Like you can have 2, 4, 6, 8, 10. All right, but what if you need an odd number of oxygens? If you need an odd number of oxygens, you're just going to have to double all of the coefficients. Maybe put a little placeholder in there to start with. All right, so put 6.5 in there to start with. But just know you're not allowed to have decimals. So if the thing that would make this work is like a fraction or a decimal, plug it in to start with, but then double everything again to get rid of it. Let's try one last problem. Yeah, here we go. C2H6O, I think that's alcohol, okay? Plus O2. Yeah, you can burn alcohol, okay? Now, again, the products are going to be always carbon dioxide plus water. That's always going to be the same. Now we got to do the balancing, though, okay? So carbons first. We've got 2 over here. We've got 1 over here. 2 carbons, 1 carbon. I'm going to put a 2 in front. Carbons are now balanced. Okay. Next up, hydrogen. we've got 6 hydrogens here. And over here, we've got 2. So I'm going to put a 3 in front. All right, and now, sometimes I have to re-click it so I can erase. I don't know why. And as always, the tricky part, the oxygens. Now, check it out. On this side, we have 1, 2, 3. We have 3 oxygens on this side. All right, because look, there's an oxygen attached to the carbons and the hydrogens. It will happen. Some of the harder problems will have that. Over here, you have 2 times 2 is 4. 3 times 1 is 3. You've got 7 on this side. Okay, you've got 7 oxygens on the product side. So what do? Is that odd number again? We'll check it out. Actually, if I put a 3 here, if I put a 3 right here, then 3 times 2 is 6, plus 1 is 7. So, yeah, we need an odd number of oxygens on the reactant side, but because there's a single oxygen in this product, then we only need an even number on this product, or on this reactant over here. All right, so you could make it work. It might require some trial and error. Okay, I'm going to upload another video where a fine gentleman does a few more sample problems, but this is essentially it. Writing the products is easy. Balancing is going to be a bit trickier. Okay, I wish you luck, everyone. Please don't forget to stop by office hours or send me a message if you have any questions. Once again, good.